Edexcel Core Pure Calculus 4 Integration using partial fractions. Partial fractions with the denominator in the form ax plus b times cx squared plus d. So previously we have looked at partial fractions with linear factors in the denominator, both singly and repeated factors. But what difference does it make if we have a quadratic factor in the denominator of the form ax squared plus b, for example? So how would we split the following into its partial fractions? So here we have x plus 5 over x plus 1, but we have a quadratic x squared plus 3 to deal with. So the question is, what would the partial fractions look like? So in this case and similar cases, the partial fractions you would set up would be for the linear x plus 1, you just have a over the linear x plus 1. But for the quadratic x squared plus 3, you need to have something linear on top. So here it would have to be bx plus c. And if you want to investigate what would happen if we didn't have the bx, for example, if we just had c over x squared plus 3, you could try it without the bx and you'll find that you'll run into algebraic problems and contradictions. So we need something linear over the quadratic. Now we multiply through by x plus 1 x squared plus 3, as we have done in previous questions. So when I multiply a over x plus 1 by x plus 1 x squared plus 3, the x plus 1 cancels out and we get x squared plus 3. And when I multiply bx plus c over x squared plus 3 by the x plus 1 x squared plus 3, the x squared plus 3 cancels out and we get x plus 1. Now, quick note, sometimes students write it in like this. It's very important that you bracket the bx plus c, otherwise the algebra will not make sense. So now looking for a nice value of x, for example, I'll look at this x plus 1, and it'd be a good idea to let x equal minus 1. So minus 1 add 5 is 4. Minus 1 squared plus 3 is 4a, and minus 1 plus 1 at the end is of course 0. So we found a is 1. Then x equals 0 is a good backup method if you are looking for more methods. So 0 add 5 is 5. 0 squared add 3 is 3a. And when x is 0, we're just left here with c times 1, so plus c. We know that a is 1, so 5 take away 3 must be c, c must be 2. And rather than just use another value of x, for example 2 or 3, a nice neat method now is to look at coefficients of x squared. So there are no x squareds on the left hand side of the expression. If I expanded those brackets, I'd have ax squared, and if I expanded these brackets, I'd have bx squared, and the a plus b coefficients of x squared must add up to 0. We know that a is 1, therefore b must be minus 1. So this algebraic expression x plus 5 over x plus 1 x squared plus 3, which would be very difficult to consider integration for, is identical to a over the linear, so that's 1 over the linear, and just be careful how you write this next term. We know the denominator is x squared plus 3, but the numerator would be minus 1x plus 2. So the neatest way of writing that perhaps is to turn it into 2 minus x. And again we've got something here that will be easier to handle when it comes to integration. So the key thing here is this quadratic factor in the denominator, the x squared plus 3. If you have a quadratic in the denominator, you need something linear in the numerator. Bx plus c is linear. Then, having multiplied all the way through by this denominator, First thing I'll do is look for a nice value of x. For example, x is -1 would be a good method. There isn't another obvious value of x to try, so I've gone straight to x equals 0. And coefficients of x squared is a good coefficient to look for as a third method. And just take care in a nice, neat way of writing the answer. So, in summary, the linear factor here, for example, the x minus 1, would just have a constant in the numerator, which is a. The repeated factor here, x plus 5 squared, so you'd need a fraction for each power. So there's a power 1 and a power 2, so you'd have b over x plus 5 and c over x plus 5 squared. And for the quadratic factor, you would need a linear numerator. So the quadratic x squared plus 4 needs a numerator which is linear, and there's the dx plus e. So if you've got linear factors, split the fraction into fractions, one each for the original factors. If there's a repeated factor, then you need a fraction for each of the powers that have been repeated. And if there's a quadratic factor, then you need a linear numerator, something of the form ax plus b. Then you multiply all the way through that left hand side and right hand side by the denominator, and if possible look for values of x which will make some one or more of the factors 0, and if necessary look at the coefficients of each power of x, starting with x squared, as that is the easiest, usually the easiest coefficient to pick out. In the next session we're going to be looking at integrating, where the denominator has the form ax plus b bracket cx plus d.